plot one versus another. The red line would be the 45-degree line, perfect prediction of the fossil record from evolution. The points are very close to that line. The R in a Spearman rank correlation test is 0.994. It's very good. It's a very good order sequence, and we've got a number of organisms in the sequence. So the reliability of this is very high, which means the divisions of plants, the major groups of plants, are coming in an evolutionary order. They're appearing in the fossil record in the order evolution would predict. Very powerful, spectacular sort of order. Now, at this point, an evolutionist, of course, would quit right here. There's no need to go any further because the case is finished. But of course, my perspective is different. I don't believe that evolution brought the plants into being in that sequence. So the sequence now becomes intriguing to me. Now I want to know what the sequence means in terms of creation. So whereas the evolutionary sequence would be satisfactory explanation to an evolutionist, it's not to me. So I'm wondering if there isn't another way to explain the sequence. So what's the order like? Going back to the very same data that was used to build the evolutionary tree, we now look at what that data, how they built that data, and what conclusions they derive from it. First of all, if you look in a paleobiology textbook, you'll learn that the evolutionary story on the plants, basically the simple story, is an evolution from algae to land plants. It's an evolution from plants that live entirely within water to plants that will ultimately live independent of water. It's a story of increasing terrestriality. It's a story of also increasing your height above the substrate, because you're floating around in water, you're not above the water level. But when you get onto land, you have the ability to grow tall. So it's also a story of increased height above the substrate. You go from early plants here that actually produce eggs and sperm that swim in the water to meet each other, to at the other end of the spectrum, something like a corn plant, where the sperm and the egg never contact the outside air, never have to swim through water or anything else. It's completely independent of standing water. So you have complete dependence on standing water at one end, independence of standing water at the other. That's the basic story, the evolutionary story of the origin of the plants. And if you look at the actual data, the similarities that group the groups together. So why do you separate the Horneophytopsida from the rest of them? There's a particular character there at 3b, which is possessed by all of the other, actually at 2b, by everything other than Horneophytopsids that unite them and thus suggest that they have an evolutionary common ancestor, and so on down the line. If you look at the list of characters that are used to define each of these things and separate out from those characters those that have to do with things that help a plant become more and more independent of water, something that helps it move water, helps it to stand straight above the substrate or so on, this would be what they would look like. I'm just going to flash through them. You won't know probably what most of these things are. But this is an example of the kinds of characteristics that are found at these various levels that help these particular plants, in contradistinction to the others, being more and more capable of existing independently of water. Now, if you take that cladogram that we had before, ignore all the characters that weren't useful for a plant to become more and more independent of water, you create another cladogram a little bit simpler that looks like this. Therefore, from this, you can actually now create a rank, an expectation of ranks of increasing terrestriality. Not evolution now. We're not talking about evolution. We're now talking about ecology. How do these plants differ in their ability to exist independently of standing water? So those with a high rank, a 7, are those that least need standing water to survive. And those that have a 1 up there actually require standing water in order for the egg and the sperm, for example, to swim together. And from this now we can produce an order of terrestriality that we can now compare with the evolutionary order. And the rank correlation there is actually just a little bit better. Not that it makes any early difference in 0.994 versus 0.995, but it's again what we're seeing then in the fossil record, getting a little bit closer to the actual data, is that the plants are entering the fossil record in increasing terrestriality. It's a measure of increasing terrestriality. Add one more thing to it, which is interesting. Not first appearance, which you would be interested in evolution. But if you're interested in ecology, you might actually be more interested in the time when the plant is most abundant, when the diversity is greatest, the center of its ecological, where it exists, the centroid of its ecological existence. For example, you might have a polar bear and a grizzly bear. They might actually overlap in geography. But most polar bears and most grizzly bears actually don't live in areas that overlap. And there's a clear order in grizzly bears when you go from the equator, where you've got a sun bear, to, as you go north, you get larger and larger bear species as you go to the largest bear species, the polar bear. And there's a certain order to the first latitude, the lowest latitude you first encounter that. But there's much more significance to actually where each bear species is most abundant geographically. And so maximum diversity makes sense ecologically. It doesn't make a lot of sense evolutionarily. But maximum diversity also correlates with the fossil record order. So the combination of the fact that terrestriality and maximum diversity both correlate with the order in the fossil record suggests that the plant divisions show not only an evolutionary order, but they also show an ecological order. So this could actually be a sequence of ecologies that actually make sense. They're